Now, for learning outcome 3, we will look into how to determine implicit and explicit functions and how to actually find the first derivative of an implicit function. So this table here explains what are the difference between an implicit and explicit function. So an implicit function is a function that has both dependent and independent variable in one equation. As you can see here, y plus x squared plus 3x minus 8. So you have y, which is usually the dependent variable, and then x is usually the independent variable. So both the variables are in one equations and they are not separated. Okay, so implicit example are like xy equals to 1. This is an implicit function as well. Okay, now let's have a look at explicit functions. So all this while in semester one, semester 2, you have been differentiating functions y in terms of x, or say v in terms of t, or s in terms of t. So all those functions that you have been differentiating is from high school as well are actually explicit functions. So y is the independent variable and x here is the, sorry, y is the dependent variable, x is the independent variable. So y is always the subject of the formula. Whereas in implicit, you don't have the subject of the formula. As in y and x is in together. And over here, y is the subject and y is in terms of the independent variable x. Okay. So an explicit function, this is an example of an explicit function. So you see, you can convert an implicit function to an explicit form or vice versa. Okay, and then you can determine the derivative. So for example, xy equals to 1 is an implicit form. And if you want to make it explicit, you need to get y in terms of x. So y is 1 over x. And the derivative, this is the derivative. This is a standard derivative that you have learned in semester 1 and also semester 2. So now, next we will look into how to differentiate these implicit functions. So now, the first key point here, when a function is stated implicitly, it is often possible to find the derived function without first having to find the explicit form. That means if you have x and y in one equation, you can act like, for example, this function, you can actually find the derivative, which is the dy dx, without getting y in terms of x. Okay, so for example, find the gradient of the tangent at 3, -4 to the circle with equation this. So this is a circle equation. And we are aware from semester 1 that if we need to find the gradient of a tangent, you need to find dy dx of the curve. So first step here, we find dy dx of this function. So as usual, when you want to differentiate x squared, you'll get 2x. When you need to differentiate y squared, just pay attention, it becomes 2y. You bring the 2 in front, copy the y, 2 minus 1 is 1. And then you need to differentiate the y, you need to add a dy dx. So whenever you differentiate a y, a dy dx will be involved. Equals to, differentiating 25, you get a 0. So applying the chain rule, pay attention again. When you have y squared, when you differentiate it, it becomes 2y dy dx. So your next step is getting dy dx, making dy dx as the subject of the equation. So you leave dy dx on the left and bring everything else to the right. So it will become negative 2x over 2y. So it becomes negative x over y. And you need to find the gradient. Therefore, you need to substitute x as 3 and y as -4 into the values here, into the function here. and you will get the gradient is 3 over 4. So therefore, the gradient of the tangent at 3, negative 4 is 3 over 4. So now we'll look at the next example. Find the gradient of the tangent at any point on a lemniscate. Lemniscate is a figure 8 curve, yeah, okay, with equation as stated here. So in order to find, we need to differentiate each component of the equation individually. So we look into one by one. You differentiate x4, you will get 4x cubed. Differentiating x squared gives you 2x. Differentiating y squared gives you 2y dy dx. And then next, you need to make dy dx as the subject of the equation. So it will become 4x cubed minus 2x over negative 2y. So when you simplify, you will arrive to this value. So therefore, on this, when you simplify further, you bring the x out, you will get this. So this is find the gradient of the tangent. No specific value, just dy dx in terms of x and y. So next, we'll look at the next example. For the curve with equation, as stated, express dy dx in terms of x and y. So therefore, now next we need to differentiate each term in the equation, in the implicit function, and simplify it further by making dy dx as the subject of the equation. So when we differentiate x cubed, we get 3x squared minus, okay, bear in mind, we still need to apply your product rule, your chain rule, your quotient rule over here. So you have minus xy. So the u is x and the v is y. So you apply product rule to differentiate this. So the easier way to do this is minus, leave the minus outside and focus on xy being the apply the product rule on the xy. So therefore, differentiating x gives you 1, copy the y, plus, write down the x, differentiating y alone gives you dy dx, plus, differentiating y squared gives you 2y dy dx, and differentiating 1 gives you 0. So therefore, next, your next step would be expand, open up the brackets, minus y minus x plus 2y, and then group the dy dx together. The terms that have dy dx together, you can leave it on the left because you need to make dy dx as the subject. So it's 2y minus x. Group this together. And then this part here, which is not attached to dy dx, you bring it to the right. So it becomes y minus 3x squared. And dy dx is y minus 3x squared over 2y minus x. So you have expressed dy dx in terms of x and y. If you're given such question and you are required to prove this, so therefore you need to differentiate each term individually. So there's chain rule involved here and there's product rule involved here. Please pay attention. So 3, you bring it in front, x plus y, 3 minus 1 is 2, and then you differentiate the content of the bracket. Differentiating x gives you 1, differentiating y gives you dy dx. This part here is 3xy, so you need to apply product rule here. That's 3x as one term, u and y is v. So I decided to differentiate the y first. You copy your 3x, differentiate the y gives you dy dx. Differentiating 3x gives you 3 different, and you copy down your y. So your next step will be collect the dy dx term together. So you expand this first, is 3x plus y squared times 1 you can bring it to the right. It becomes minus 3x plus y squared. And then 3x plus y squared times dy dx. You can leave it on the left. And then this term here, 3x dy dx, you can bring it to the left because we are collecting the dy dx term on the left. And the right becomes 3y minus with what I told you just now, you bring this term to the right after multiplying by 1. Okay, so now you have dy dx terms on the left and the non-dy dx terms on the right. Your next step is simplifying. So you divide, you categorize it together, collect the dy dx coefficients together, and you divide. So you divide the right hand side with the left hand side coefficient of dy dx. The 3 gets cancelled out because you divide the 3 out. And now you have this, but it's still not, it still doesn't look like your answer. So there's some modification required. You need to multiply with x plus y over x plus y. It's like as if you're multiplying by 1, but you're just changing the form of the answer. So you continue to multiply with x plus y over x plus y. Please work this out. It's not just normal algebra. And then you expand this individually, and the y cube will get cancelled out, and you will arrive to the final answer, which is this. So please work this out on your own. If you have any questions related to these slides, please post it on the Padlet link provided in OnVision under week 1.